Download this code from codegive.com, link in the description below. OK, let's dive deep into API security, focusing on throttling, rate limiting, and DDoS mitigation. This will be a comprehensive guide with explanations and code examples, primarily in Python using Flask, but the concepts apply across languages and frameworks. Table of Contents. 1. Introduction to API security threats. Understanding DDoS, rate limiting, and throttling. Why is API security important? 2. Rate limiting techniques. Token bucket algorithm. Leaky bucket algorithm. Fixed window counter. Sliding window log. Choosing the right algorithm. 3. Throttling concepts and implementation. Differentiating throttling from rate limiting. Throttling use cases, example user plans. Implementation details. 4. DDoS mitigation strategies. Identifying DDoS attacks. Layer 7, application layer, defenses. Leveraging CDNs and cloud providers. Web application firewalls, WAFs. 5. Code examples, Flask/Python. Simple rate limiting decorator. Token bucket implementation. Redis integration for scalability. Example throttling based on user type. 6. Advanced considerations. Authentication and authorization. Monitoring and logging. Dynamic rate limiting. API gateways. 7. Conclusion. 1. Introduction to API security threats. Understanding DDoS, rate limiting, and throttling. DDoS, distributed denial of service, a malicious attempt to disrupt normal traffic of a server, service, or network by overwhelming it with a flood of internet traffic. The traffic originates from multiple, often compromised, sources. The goal is to make the resource unavailable to its intended users. Rate limiting. A technique to control the rate at which users or clients can make requests to an API within a given time window. It limits the number of requests allowed. For example, allowing 100 requests per minute. Throttling. Similar to rate limiting, but often more sophisticated. Throttling can take into account factors beyond just the number of requests, such as the complexity of the request, the user's subscription plan, or the overall system load. It might dynamically adjust the rate limits based on these factors. Think of it as a smart rate limiter. Why is API security important? Prevents service overload. Without protection, an API can be overwhelmed by excessive requests, leading to performance degradation or complete failure, ddos. Protect infrastructure costs. Excessive API usage can result in high infrastructure costs, bandwidth, server resources. Rate limiting and throttling help control these costs. Prevent abuse. APIs are often used for valuable data or functionality. Uncontrolled access can lead to data scraping, abuse of resources, or fraudulent activities. Maintain quality of service. Rate limiting ensures that all users can access the API without being negatively impacted by a few heavy users. Security. Throttling can help mitigate brute force attacks. 2. Rate limiting techniques. Token bucket algorithm. Concept. Imagine a bucket that holds tokens. Each request consumes a token. The bucket is refilled at a constant rate. If the bucket is empty, the request is rejected. Advantages. Allows for bursts of requests, as long as there are tokens in the bucket. Easy to understand and implement. Asterisk disadvantages. Asterisk can be slightly less precise than other algorithms. Asterisk leaky bucket algorithm. Asterisk concept. Asterisk requests enter a queue, the bucket. The queue is processed, leaked, at a constant rate. If the queue is full, new requests are dropped. Asterisk advantages. Asterisk smooths out traffic more effectively than the token bucket. Asterisk disadvantages. Asterisk more complex to implement. Asterisk fixed window counter. Asterisk concept. Asterisk divide time into fixed windows, example 1-minute intervals. Count the number of requests within each window. If the count exceeds the limit, reject requests until the next window. Asterisk advantages. Asterisk simple to implement. Asterisk disadvantages. Asterisk can be easily bypassed. For example, if a user makes 99 requests at the end of one window and 99 requests at the beginning of the next, they effectively made 198 requests within a short period. Asterisk sliding window log. Asterisk concept. Asterisk maintain a log of request timestamps within a sliding time window. Count the number of requests in the log. Reject requests if the count exceeds the limit. Asterisk advantages. Asterisk more accurate than the fixed window counter. Avoids the edge case problem. Asterisk disadvantages. Asterisk more complex to implement, requires storing request logs. Asterisk choosing the right algorithm. Asterisk simplicity. Asterisk fixed window counter is the simplest. Asterisk accuracy. Asterisk sliding window log is the most accurate. Asterisk bursting. Asterisk token bucket allows for short bursts of requests. Asterisk smoothing. Asterisk leaky bucket smooths traffic. Asterisk scalability. Asterisk consider how the algorithm will scale as your API usage grows. Using a distributed cache, like Redis, can help with scalability. 3. Throttling concepts and implementation. Asterisk differentiating throttling from rate limiting. Asterisk rate limiting is a subset of throttling. Throttling is more comprehensive and can take into account factors beyond just the number of requests. Rate limiting is focused on how many. Throttling considers who is making the requests and what they are requesting. Asterisk throttling use cases, example user plans. Asterisk free tier versus paid tier. Asterisk users on a free tier might have stricter rate limits than paying customers. Asterisk different API endpoints. Asterisk some endpoints might be more resource intensive than others and therefore have lower rate limits. Asterisk time-based throttling. Asterisk you might throttle requests during peak hours to maintain service quality. Asterisk abuse prevention. Asterisk if a user is suspected of abusive behavior, their rate limits can be dynamically lowered. Asterisk implementation details. Asterisk metadata. Asterisk throttling often requires additional metadata about the request, such as user ID, API key, or request type. Asterisk configuration. Asterisk throttling rules are typically configurable and can be changed dynamically. Asterisk custom logic. Asterisk throttling often involves custom logic to determine the appropriate rate limits based on the specific context. 4. DDoS mitigation strategies. Asterisk identifying DDoS attacks. Asterisk sudden spike in traffic. Asterisk a significant and unexpected increase in traffic to your API. Asterisk high latency. Asterisk increased latency for legitimate users. Asterisk service unavailability. Asterisk the API becomes unresponsive or returns errors. Asterisk traffic from suspicious sources. Asterisk traffic originating from a large number of different IP addresses or from regions where you don't expect legitimate users. Asterisk unusual request patterns. Asterisk requests with odd headers, malformed data, or that don't follow your API's specifications. Asterisk layer 7, application layer, defenses asterisk. Asterisk rate limiting and throttling, critical implement strict rate limiting and throttling to prevent attackers from overwhelming your API. Asterisk CAPTCHAs asterisk use CAPTCHAs to distinguish between human users and bots. Asterisk web application firewalls, WAFs analyze HTTP traffic and block malicious requests based on predefined rules and signatures. Asterisk request filtering asterisk filter requests based on headers, user agent, or other criteria. Asterisk geolocation blocking asterisk block traffic from regions where you don't expect legitimate users. Asterisk leveraging CDNs and cloud providers asterisk. Asterisk content delivery networks, CDNs distribute your API content across multiple servers, making it harder for attackers to overwhelm a single server. Asterisk cloud providers, AWS, Azure, GCP cloud providers offer DDoS protection services that can automatically detect and mitigate attacks. They have the infrastructure and expertise to handle large-scale attacks. Asterisk web application firewalls, WAFs. Asterisk signature-based detection asterisk WAFs use predefined signatures to identify known attacks. Asterisk anomaly detection asterisk WAFs analyze traffic patterns and identify anomalies that might indicate an attack. Asterisk custom rules asterisk you can create custom rules to block specific types of requests or traffic patterns. Asterisk examples asterisk AWS WAF, Azure Web Application Firewall, Cloudflare WAF. 5. Code examples, Flask/Python. Explanation of the code asterisk. Asterisk import statements asterisk Flask for the web framework, time for time-related operations, Redis for using Redis as a distributed cache, and functools.wraps to preserve function metadata. Asterisk Redis configuration asterisk establishes a connection to a Redis server. Crucially, you'll need a running Redis instance for this to work correctly. Asterisk rate underscore limit decorator, fixed window counter. Asterisk takes limit, requests per window, and per, window duration in seconds, as arguments. Asterisk creates a unique key for each IP address and function name in Redis. This allows you to track the rate limit for each client individually. Asterisk Redis underscore client dot increased, key, atomically increments the counter for the key in Redis. If the key doesn't exist, it creates it and sets its initial value to 1. Asterisk checks if the count exceeds the limit. If so, returns a 429 too many requests error with a retry underscore after header indicating how long to wait. Asterisk Redis underscore client dot expire, key, per, sets an expiration time for the key in Redis. After the window duration, the key will be automatically deleted, resetting the counter. Asterisk token bucket class asterisk. Asterisk implements the token bucket algorithm. Asterisk consume, tokens, attempts to consume a specified number of tokens from the bucket. Asterisk refill, refills the bucket based on the fill rate and the elapsed time since the last refill. Asterisk get underscore token underscore bucket function asterisk. Asterisk gets the user's token bucket from Redis or creates a new one if it doesn't exist. Asterisk retrieves bucket data from Redis using key. Asterisk token underscore bucket underscore rate underscore limit decorator asterisk. Asterisk fetches the user ID from the request headers, you'd typically get this from authentication information. Asterisk retrieves the user's token bucket from Redis. Asterisk refills the bucket. Asterisk consumes a token. Asterisk if successful, executes the decorated function. Otherwise, returns a 429 error. Asterisk throttling decorator asterisk. Asterisk gets the user type from the request headers. Asterisk looks up the rate limits for the user's plan in the user_plans dictionary. Asterisk applies the appropriate rate limits. To run this code asterisk. 1. Install dependencies asterisk. 2. Start Redis asterisk. Make sure you have a Redis server running, usually on localhost 6379. You can install Redis from your system's package manager, example apt-get install Redis server on Ubuntu/Debian. 3. Run the Flask app asterisk. 4. Test the API asterisk. Use curl or a similar tool to make requests to the API endpoints. 6. Advanced considerations. Asterisk authentication and authorization asterisk. Asterisk authentication asterisk. Verify the identity of the user, example using API keys, JWTs, OAuth. Asterisk authorization asterisk. Determine what resources the user is allowed to access, example based on roles or permissions. Asterisk importance asterisk. Authentication and authorization are essential for secure APIs. Rate limiting and throttling are much more effective when you can identify and track individual users. Asterisk monitoring and logging asterisk. Asterisk monitoring asterisk. Track API usage, error rates, and rate limit violations. Use monitoring tools like Prometheus, Grafana, or Datadog. Asterisk logging asterisk. Log API requests, responses, and rate limiting decisions. Use logging tools like Elk, Elasticsearch, Logstash, Kibana. Asterisk benefits asterisk. Monitoring and logging provide valuable insights into API performance, security threats, and usage patterns. This information can be used to optimize rate limits, identify potential attacks, and troubleshoot issues. Asterisk dynamic rate limiting asterisk. Asterisk adapt to system load asterisk. Dynamically adjust rate limits based on the overall load on your API servers. Asterisk react to attacks asterisk. Automatically lower rate limits for suspicious users or IP addresses. Asterisk implementation asterisk. Use a monitoring system to track system load and automatically update rate limits based on predefined thresholds. Asterisk API gateways asterisk. Asterisk centralized management asterisk. API gateways provide a central point for managing all of your APIs, including rate limiting, authentication, authorization, and monitoring. Asterisk examples asterisk Kong, TYK, APG, AWS API Gateway, Azure API Management. Asterisk benefits asterisk. API gateways simplify API management, improve security, and enhance performance. They are highly recommended for complex API deployments. 7. Conclusion. API security is a critical aspect of modern web development. Rate limiting, throttling, and DDoS mitigation are essential techniques for protecting APIs from abuse, overload, and malicious attacks. By understanding the different algorithms, implementation details, and advanced considerations discussed in this tutorial, you can build more secure and reliable APIs. Remember to continuously monitor your APIs, adapt your security measures to evolving threats, and leverage the power of API gateways for centralized management.